Hello students, welcome to my channel Engineering Education. Please subscribe my channel. Thank you. In this video we are going to solve problem 12.8 chapter 12 positive displacement machines, applied thermodynamics by TDS Top and McConkey. The statement of the problem is a single acting single cylinder air compressor running at 300 revolution per minute is driven by an electric motor. Using the data given below and assuming that the bore is equal to stroke, calculate the free air delivery, the volumetric efficiency, and the bore and stroke. Data is air inlet conditions are 1.013 bar and 15 degrees C. Delivery pressure is 8 bar. Clearance volume is 7% of swept volume. Index of compression and re-expansion is 1.3. Mechanical efficiency of the drive between motor and compressor is 87%. Motor power output is 23 kilowatt. So extracting data from the given statement, also we have that given data is first, this is single acting single cylinder compressor, so we can say that this is single stage compressor. Second, we have speed, compressor speed, that is N is equal to 300 revolution per minute. Stroke and bore are equal. Air inlet conditions are P1 is 1.013 bar, while temperature T1 is 15 degrees centigrade, which is 288 Kelvin. Delivery pressure P2 is 8 bar. Also clearance volume is 7% of the swept volume. Adiabatic index, polytropic index is 1.3. Mechanical efficiency is 87%. Motor power output are also called motor power, that is equal to 23 kilowatt. So based on this data, we have to find the free air delivery, FAD, free air delivery. Second, we have to find the volumetric efficiency. Third, we have to find the bore and stroke of the cylinder. So let's start to solve part number 1 to calculate the free air delivery. So for that As we know that mechanical efficiency for this case is the ratio of indicated power and shaft power, and shaft power is basically the motor power or motor power output. So rearranging this expression, indicated power is equal to mechanical efficiency into motor power. So we know about these both values, mechanical efficiency and motor power. So from this we will find indicated power. So putting the values, mechanical efficiency is 87%, while motor power is 23 kilowatt. So multiplying this, we get indicated power which is equal to 20010 watt. Now we also know that for single stage compressor, the indicated power is equal to n over n minus 1 P1 V dot into P2 by P1 power n minus 1 by n minus 1. So putting the values, we can find the value of V dot, which is unknown in this expression. Remaining pressure, polytropic index, these values are given. Only the unknown thing is V dot. V dot is, in this case, is actually the free air delivery. So we are interested to find this V dot. So for that, putting the values, indicated power is 20010 watt and n is 1.3, and it is 1.3 minus 1. P1 is 1.013 to 10 raised to power 5. V dot is, we are finding it also. P2 is 8 bar, P1 is 1.013 power 1.3 minus 1 by 1.3 minus 1. So simplifying this, we get that V dot is equal to 20010 over 267165.14, which is further equal to 0.0749 cubic meter per second. So this is the free air delivery which was required in part 1. In cubic meter per minute, the value of free air delivery will be 4.49 cubic meter per minute. We will multiply 0.0749 with 6, so multiplying by 60, so we will get the value of 4.49. so as this value has been actually we got it from here like this, 0.0749 into 60, so we get this value. Now in part 2 we have to find the volumetric efficiency. For that we have a general expression for volumetric efficiency, which is 1 minus Vc by Vs into P2 by P1 power 1 over n minus 1. So putting the values, 1 minus clearance volume is 7% of the swift volume divided by swift volume into P2 is 8 bar while P1 is 1.013 bar, 1 over 1.3 minus 1. So simplifying this, we get 1 minus 0.07 into 3.8996. So we get 1 minus 0.273, which is further equal to 0.727. So the value of volumetric efficiency is 72.7%. Third, we have to find the stroke and bore. So for that from PV diagram we see that VA is equal to Vs plus Vc. We have carried out these calculations earlier in the previous problems as well. So this is easy now. So 0 swift volume plus clearance volume is 7% of the swift volume. So it will become 1.07 Vs. Also to find Vd, so this is VA. VA is 1.07 times Vs. Also to find Vd, we have an expression for this, Vc into P2 by P1 power 1 over n. So putting the values, we get 0.07 Vs P2 by P1, which is 8 by 1.013 and 1 over 1.3. So simplifying this, we get 0.343 times Vs. So the value of Vd comes out 0.343 times Vs. Now we are going to take the difference of these two values, VA and Vd, So VA minus VD is equal to 1.07 times Vs minus 0.343 Vs. So the difference is 0.727 times Vs. So we get VA minus VD is equal to 0.727 times Vs. Also, from part 1, we know that free air delivery is nothing but this is equal to VA minus VD into N. So that is 4.49 cubic meter per minute. So to convert it into cubic meter, again, so we will divide it by N. So when we divide it by N, that comes out VA minus VD is equal to 4.49 by N. So N value is 300. 4.49 divided by 300. So over here we have expression A, suppose, and we also have the value of VA minus VD here. Let's suppose this is B. So equating these two values, we will get that 0.727 times Vs will be equal to 4.49 by 300. So simplifying this and finding the value of swift volume from this, we get 4.49 divided by 300 divided by 0.727. So simplifying these values, we get the value that is 0.0206 cubic meter. So this is the value of swift volume, 0.0206 cubic meter. Now it's very easy to find the bore and stroke of the cylinder, because we know that swift volume is equal to pi by 4 b square. In this case, the bore and stroke are equal, so stroke will also become b. So let we first find the bore. So putting the values, swift volume is 0.0206 pi by 4 b cube. So solving it for b, it will become b cube is equal to 4 into 0.0206 by pi. So we get b is equal to 0.297 meter. So also b is equal to stroke, so the value of stroke will be also 0.297 meter, or in millimeter it will be 297 millimeter. So we can also write like this: bore is equal to stroke and it is equal to 297 millimeter. So this is the solution of problem 12.8. Thanks for watching. Please like and comment on my videos. Also subscribe my channel to get new videos.